Okay, for 3D objects, degree of freedom, interesting. Let us first look at the translation, linear movement. I've got the box here. Can I move the box in this direction? Can I? It's space, okay? I can move it in Z direction. I can also move it in Y direction, and I can also move it along the X direction. That's easy. It's a 3D object. I can move it in Z. 3 dimensions got 3 axes. So the object can be moved in 3 different directions. So I can also rotate in all 3 axes. I can rotate the object here for along the Y-axis. I can rotate the object here along the X direction, and I can also rotate the object here along the Z direction. So in simple words, a 3D object has got 6 degrees of freedom. There are 2 translation and 2 rotation. Is that clear?
3 translation and 3 rotations.
3 translations and 3 rotations. Is that clear?
Yes, sir.
Yes, sir.
Okay. So the 3D object has got 6 degrees of freedom. Can you tell me how many degrees of freedom a 2D object has?
3.
4, sir.
4. Anyone else?
3 degrees of freedom.
3, sir. Sir, 3 degrees of freedom.
3 degrees of freedom.
3 degrees of freedom. I'm more interested in the fourth degree. If anyone can figure out the 4th degree, I'll be very happy. Maybe I'll get a Nobel Prize for it. Okay, an object. They are in 2D, there are only 2 axes, Y and X. So I can move the object in this direction. I can move the object in this direction. Okay, so it always moves in the XY plane. So I've got 2 degrees of translation. I can also rotate it. So that's my 3rd degree of freedom. So in simple words, a 2D object has got 2 translation and 1 rotation. Is that clear?
Yes, sir.
Yes.
So for a 3D object, there are 6 degrees of freedom. For a 2D object, there are 3 degrees of freedom. So let's move on. So let us look at this example and see if the common sense prevails. I've got this bar which is welded to the bar down here, and this is fixed to the ground. Okay, so a bar, that's this one, it's welded here, which is fixed to an object, another bar which is fixed to the ground. Now, my question is this a 2D or a 3D object?
Sir, 3D.
It's a 3D object. So, how many degrees of freedom this bar has? 6? And that's 6 or 3?
It's 3D, right? So it should have 3 rotational and 3 translational reactions.
Okay. So it's a 3D, and you're telling me that it's got 6 degrees of freedom. So 6 degrees of freedom. Can you tell me, can I move this bar up? Can I?
No.
No, sir.
No. Can I move this bar in any X, Y, Z direction, can I?
No.
No. Okay. Can I rotate the bar along any of my X, Y, Z axis?
No.
Then how come it has got 6 degrees of freedom?
Yeah, the weld wouldn't have any degree of freedom.
Yes, yes. So a 3D object, ideally, if there's no constraints, has got 6 degrees of freedom. But if it is held in a way that it cannot move, then you have to find out how many degrees of freedom it has. So in simple words, this bar, I cannot move in X, Y, Z, so I will get, where is it? I will get the I will get the reaction for forces, reactive forces in all 3 axes. I cannot rotate in any of the 3 axes. I will get the 3 reactive moments also. Is that clear?
Yes, sir.
Yes.
Yes, sir.
So it says here, this joint constrains 3 forces and 3 moments, that is along all the degree of freedoms. So it doesn't have any degree of freedom because it's been held. Clear?
Yes, sir.
Yes, sir.
Okay, now let's look at this 2D. Let's just look at this bar here, this bar. Is fixed to the wall. I cannot move it in X, Y. I cannot rotate it. So I will have 3 constraints, 2 in translation and 1 in rotation. So ideally it's a 2D, so there should be 3 degrees of freedom, but it's being constrained, so it doesn't have the degree of freedom, rather we've got the reactive forces. If I look at this is fixed here. If I look at this part only, and try to rotate, I'll cut it off from the surrounding. So I've got that here. I've got 3 constraints. Same 3 constraints apply on the other side. You remember this? Same forces, but opposite direction on the other component. Is that clear? You remember this?
Yes, sir.
Okay, now let's look at this. How many degrees of freedom are constrained by this joint? I need the answer.
Five.
My question now is, how many degrees of freedom it has?
1.
One.
1. Yes. So just let me explain it a bit. I cannot move the top bar, the bar that is rotating, this one. I cannot move it in X, Y, or Z direction because it is fixed at the pivot here. So it does not have any degree of freedom in the translation. Now let's look at the rotation. It rotates along this axis. So yes, I've got 1 degree of freedom. Now let's look at the other. I cannot rotate it along this direction because the joint won't allow me to do that. And I cannot rotate it along this direction because the joint doesn't allow me. So in simple words, this joint has got 1 degree of freedom and 3 degree of constraints. Is that clear? So if I have to do the analysis on the rod, I will have 5 reactive forces. That's my rod. I've got 5 reactive forces, 3 in translation because I cannot move it in X, Y, and Z direction. And there will be also rotation, 2 rotational reaction moments. One is here and the other one is here. If I look at the block, same thing. If I look at the pin on the block, Same forces, but in opposite direction applies here also. Is that clear? Okay, now let's look at this 2D. I've got a pivot here. It's a pivot. So the rod can move in this direction, but the rod cannot move in this or this direction. So I will have reactive forces in the XY. So that's here. You can see that. There's no reactive moment here because it is allowed to move, rotate. Similarly for the joints, won't go into the detail. So look at this one. It's a bearing. So it allows rotation about one axis only and does not allow rotation on the other two axes. So I will have two reactive moments and prevents all relative displacement of the shaft. I want to move the shaft in this direction, and up, down. I cannot do that because of the constraint of this block here. So therefore, it has got only 1 degree of freedom and 5 constraints, so 5 reactive force. So if I look at the rod can rotate only in this direction. So I do not have a reactive moment in that, but I've got the reactive moment in other directions. And it cannot Now let's look at this one. I've got shaft rotating and it slides also in out. So how many degree of freedom it has?
2.
2. And it's got 4 constraints. So basically it's got a degree of freedom in one axis, excuse me, and constraint in other 2 axes. Similarly, it's for the linear. So I'll just move on. Let's look at this one. How many degree of freedom?
2.
2, sir.
Okay. 3. And it's got 3? You got 3 or 2? Is it rotating in 2 directions? So it can rotate only along 2 axes. So we've got 2 degree of freedom. It cannot rotate on 1 axis. So that's been constrained. And the rod, the joint cannot move in X, Y, Z direction. It cannot slide. Remember, it cannot slide on this one as it's showing here. So therefore, what you've got here, if I look at the rod that's rotating, so I've got 1 reactive moment and 3 translative moments, 3 translative forces. Okay, now tell me.
Sir, 4.
4. Can you explain me?
Sir, 3 only.
Sir, 3 is right, because it cannot move in
Yes.
the... Sir, 3.
Yes, I cannot move the socket in X, Y, Z direction, but I can rotate it. I can rotate the ball along any axis within the moving limits. I can rotate it in any direction. So it does not have any constraint in rotation, but it has got constraint in translation. So there will be no reactive moment. There will be only reactive force. So in simple words, yes, I cannot move the ball socket in X, Y, Z direction, but I can rotate. Is that clear?
Yes, sir.
Okay, now let's look at this one.
Two.
How many in translation and how many in rotation?
Two rotation, translation.
Is that two rotation?
Sir, one in rotation and one in
Two
translation.
One rotation. Because
Two translation, have a look.
Sir, one each.
Sir, one
Yes, one each. So one in rotation and one in translation. So you will have reactive force in the other two types. We won't go into it. And similarly, that's for the two. We have already covered it. Okay. Now tell me.
now it has two rotation.
Wait. How many degree of freedom?
Sir, three.
Three.
Okay, so it can rotate in one axis. So I'll have two reactive moments. Am I right?
No, sir, it can rotate in like
Yes.
two axes
It-
and translate in one axis.
Yes, so basically it can rotate in two axes. So I have one reactive moment. It can move along one axis, so I'll have two reactive